Hey everybody, today we're going to talk about dilations, which is one of the last pieces of the puzzle when it comes to transformations. And this is a little unique compared to what we've been doing before, so I think this will be pretty interesting. Alright, so to start, let's see if I can speak this time. To start, we're going to talk about rigid transformations just briefly. Those are the three big ones we learned about earlier. Okay, so the first one was translations. The second one was reflections. And the third one was rotations. Okay, translations were also known as shifts. Reflections were also known as flips. And rotations were also known as twists. Okay? Now those all preserved congruency. Those are what we call congruence or congruent transformations. This fourth one, dilations, is not a congruence transformation. It's actually what's called a similarity transformation. All right. So anyway, it's a similarity transformation that requires a scale factor, which is sometimes represented by the letter R. Okay. Now there's two types of dilations. Well, there's three, but we're only going to worry about two. Reduction and enlargement. Reduction is going to make an image that is smaller than the pre-image, and an enlargement is going to make an image that is larger than the pre-image. Okay, so a reduction is a dilation where that or when the scale factor is between 0 and 1. Okay. You can put an absolute value there, but we're not going to worry about that yet. It's going to be assumed that it's positive. And then enlargement is going to be dilation, where the scale factor is greater than 1. Okay? And that makes sense. You know, think about that. If you're multiplying something by something larger than 1, the product would be larger, assuming that R is positive the number is positive to begin with, because remember, it's distance, and distance cannot be negative. And if you multiply something by what is a proper fraction, you're going to get a resulting smaller product. The scale factor is the ratio of corresponding elements of a pre-image and image. Now there's an example here where you can use a ruler. I actually don't like this example because the way it comes out with a ruler is not very useful. So I'll show you another example other than that. I just don't really care for that one. Now these aren't too bad. Okay, let's check these out. So this is asking us to discover the scale factor and then determine whether or not it is a reduction or an enlargement. So first things first, this is our pre-image, that's our image. We know that because the primes are here. So we know we're starting here and going here. So it's getting bigger, so clearly we can say it is an enlargement. Okay. Now the distance from what's called the center of the center point, the center of dilation, is going to help us here. So the distance for let's say point B is 18. Right? So B, let's say distance is 18. B prime is going to be these added together, so that's going to be 31. Okay. Now to find the scale factor, think of it this way. Let's do this algebraically first. So the scale factor times, let's say, an element of the pre-image would give us the image, right? So if we solve that algebraically, right? Let's say we were to solve for the scale factor, divide both sides by the pre-image, or let's say the measurement of the pre-image. You know, the pre-images on the left-hand side would cancel. And we're going to have scale factor equals the element of the image over the element of the pre-image. And this will make sense in a moment. So let's think about that. The pre-image is 18, the image is 31. So we can create a ratio here. We're going to have 31 over 18. And that would actually be our scale factor. If you were to multiply any of these elements by this, you're going to get the resulting image. Okay, and this is clearly larger than 1, so this is an enlargement. Okay, and this is an interesting one. Let's go ahead and take a look at this. So our pre-images ABC are images A prime, B prime, C prime. So this is clearly an enlargement. All right. And let's check this out. So from B to C, diagonally is 1. It's a 1 diagonal, right? From B prime to C prime, it's 2 diagonal. So guess what? Yeah, you can already see where this is going. Let's check that again, though. Check this out. So from A to B, it's going to be 3 across, 1 up. Well, is it 6 and 2? Sure is. 1, 2, 3, 4, 5, 6, 2. So it's double. The scale factor is 2. Is there a more scientific way of doing this? Yes, there is, and you'll learn that in a moment. But that's just like the concept of it. All right. Now down here, let's do this a little more exacting way here. So let's start with, I don't know, F. The coordinates of F are 0, 2. The coordinates of F prime are 0, 5. Okay, so remember, it's image over pre-image. So image is 5, pre-image is 2, so 5 over 2, or 2.5. That's our scale factor. If you multiply these values of the coordinates by 2.5, you're going to get the resulting image points. So just try that as an example here. We got 2 comma negative 2 here. So G is 2 comma negative 2. If I multiply let's try that in English. If I multiply this by 2.5, I'm going to get the resulting 5. Okay, so, and G prime is 5, negative 5. The scale factor works. Okay, and that would obviously be an enlargement. Okay, actually pause that for 1 second. Okay, so let's check this one out. Now, this is a little harder to read, and these types are always that way. It's definitely a reduction. And let's use the coordinate method here. So H is 0, 2. H prime is 0, 1. Yep. 1 over 2. That's our scale factor. It's half the size. This is the best way to figure out the scale factor using coordinates by far. Okay, we're not going to do all of these, but we're going to do the first one together. So dilation of up to about the origin. So about the origin means that's the center point, but that's going to be what we use all the time for these. Let's write the coordinates here. So W, X, Y, and Z. So W is going to be negative 1, 1. X is negative 1, 2. Y is 0, 2. And Z is 1, negative 1. So dilation of 2 means we're going to multiply by 2, scale factor of 2. So we're going to multiply all these by 2. Okay, so we're going to say W prime, negative 2, 2. And this is going to be negative 2, 4. And Y prime is going to be 0, 4. And Z prime is going to be 2, negative 2. So negative 2, 2, 1, 2, 1, 2. That's W prime. Negative 2, 4, 1, 2, 1, 2, 3, 4. That's X prime. Y is 0, 4. And then Z is 2, negative 2. So, and this should be double the size, and sure enough it is. Okay, should be pretty straightforward. All right, and the last ones, I'm not going to do this for you. I want you to do this. So for this one, you're going to graph these points, okay, and then you're going to write down, well, you already have the coordinates. You're then going to multiply them by a half, so it's going to be a reduction. You're going to write the new coordinates of those points and then graph them, and it should result in a smaller rectangle. Okay. Here you're going to add up the perimeter. We'll find the perimeter of the pre-image, find the perimeter of the image, and see if it has the same scale factor as the one given to you. See if it's dilated by a factor of 1/2. Same thing with the area. Remember to multiply the length by the width in order to find the area, and see if the areas also have the same scale factor. I'd be curious to see what you think or what you find. Let's do one of these. I'll show you a real easy trick to find the scale factor being given the coordinates. So you're given the coordinates of the pre-image and you're given the coordinates of the image. You're asked to also find whether or not it is a reduction or it is an enlargement. Well, you can tell immediately that this is an enlargement. The numbers are getting larger, not smaller. So, well, by larger I mean the integers are going further in that direction. Even though negative 4 is technically smaller than negative 2, it's getting bigger on a grid. Okay. So this is an enlargement. You can just tell by the way I just said. And now, if you can find a number 1, right, and then the resulting number, it would be this over that number, because it's image over pre-image. So negative 2 over negative 1 is 2. The scale factor is 2. if you couldn't do that, you could find any number. So 4 over 2 is 2. You just divide the image by the pre-image, and that'll give you the scale factor. See that a little better. So it's pretty straightforward. Pick a point that is an image point, divide the coordinate by the corresponding pre-image coordinate, and then you're good. So that should take care of that. Now the homework tonight, let me zoom out a little bit. The homework tonight, where is it? Right here, dilation practice. You're simply going to write down the coordinates of the pre-image, and then you're going to multiply them by the scale factor, write the new coordinates, and then graph the new image on the grid. And it should result in either a larger one or a smaller one. Okay? So let me know if you have any questions. I'm going to extend this by a day since I was so late getting these notes up today. And then tomorrow we'll be basically doing the last piece of the puzzle for the unit. All right, thanks, guys.